Hello, everyone. Welcome to the Expert's Guide to Android Development Tools. I'm Tor Norby, tech lead for Android Studio, and with me on stage here, I have a number of key members from the Android Studio team. So do you want to introduce yourselves?
Hello, I'm Esteban.
Hi, I'm Shiva. I work on the debugger.
Hi, I'm Catherine.
And hi, I'm Jerome, and I work on the build system.
So the way this is going to work is that we're going to show you some of our favorite features and some features that we think you may not know, but that you'll find very useful once you do. If you're an expert studio user, you might know some of these things. We want to make sure that everyone has heard some of these secrets, even if you already know it. You can be very proud if you do. So we hope that you'll learn something from this. And so first we'll have an editor demo from Esteban, and then Shiva is going to be showing the debugger, Catherine, native tools, and Jerome at the end with the build system. So with that, I'm going to turn it over to Esteban, who's going to be showing the source editor.
Hello, everyone. We're going to switch to the demo machine now. Right. Can you guys see? Yeah, that's good. So in the next 10 minutes or so, I'm going to show you 10 of my favorite features of the editor. You know how coding all day is, right? One of the things you try to avoid is touching the mouse, which is like 10 miles away from where you are, right? And learning all the shortcuts. So IntelliJ has several configurations of shortcuts. I will have, while I go through the demo, all the shortcuts written down there. But there's one tip. If you're a multi-platform, there are two different shortcut setups for Mac. One that is Mac-friendly, and the other one that is compatible with other platforms. So if you hear me speaking a shortcut out loud, I'm probably going to be using the one that is common across all the platforms. So let's begin. Just before we do the editor part, there are two tips that I want to show you for configuring the general IDE. The first one is the command line launcher. So I don't know if you guys know, but you can go and say, create command line launcher, and that will create this file that you can call from anywhere to start Studio. That's cool. It's handy. You're in a console and you want to start Studio, you just type Studio. That's pretty neat. But it does more things than that. So I just created that. I need to put in the password. And done. I'm going to go to a console. Can you guys see? Yeah. If I do Studio, --help, that's the shortcut that I just created. But you can see that there are more options than just Studio. There is diff, and there is merge. I have a diff that I ran before. This actually opens Studio's diff. Where is it? It's gone. This is one of the best diffing tools that I've used, and it's really cool to be able to have it as a command line tool. You can set it up to your Git tool or whatever, and then you'll be using this that you'll be hopefully familiar with, and you can use this all the time. You can also do merge from the command line too, and it works. So that's one handy thing to have. The next one I want to show you is, you have a large project, and effectively you run out of memory in Studio, and things go bad, right? So if you wanted to edit the memory settings, you need to go to a VM options file, right? How many of you have been to the VM options file and changed the memory? Okay, that's a lot of people. The main thing is like, where was that file? You go like settings / whatever. So there is an option here that was recently added that you can say, edit custom VM options. You guys know that you should not edit the VM options inside a Studio installation, right? The next time you update, it's going to say, oh, what did you do? So you do this one, and it asks, do you want to create a custom one? And it opens it up for you, and you can go and set all the flags you want there. If you want to know where it is, someone was super excited about this. If you want to know where it is, you can press Alt F1, and you can reveal this file somewhere else. For example, you can reveal it in Finder. Just pressing 8 or going down there will open the Finder to where this file is, and you can do whatever you want. Right, that's for VM options. So I have everything set up now, and now we're going to go into the editing tips. These are my 10 favorite tips of editing in Android Studio, powered by IntelliJ. The first one is Control-Shift-J, right? You guys know there are shortcuts to join lines. Well, this one is smart one, and if you're joining strings, it actually removes the operations and gives you the full string.
I think you lost the ID.
The ID.
That's me. Can we go back to the demo machine?
pushing the button.
Hey! Let's do it again. I was talking about, I'm looking at my screen, and here it looked beautiful. Ctrl-Shift-J is a smart join, and it removes the plus operations when joining a string. So that's pretty handy. There is also the option of, and this is quite powerful, if you open the intent menu on a string operation with plus, there is the option to copy the concatenation text to the clipboard. So IntelliJ figured out that all the components here are static, or it knows the values. And the full string has been now copied to the clipboard, and I can paste it here, and it's the full thing. Operations have been done. Thank you. The next one I want to show is the difference between enter and tab. When you want to change a function, in this case, let's say we want to compare two strings, and I'm calling the function contains, but it should be equals, right? So I type E, this suggests equals, and I type enter, this happens.
Could we switch back to the...
But you guys know that if you type tab instead of enter, there you go.
It's good over there.
That's a pretty handy one to know, because it's usually backspace, what did it? The next one I wanted to show you is the powerful of the context understanding that the IntelliJ editor has. If you are inside this is a common pattern, right? You have an object, you say, is this object an instance of something? If you are inside this if, things happen, right? So if I do O dot, the suggestions I get there are not for object, are for context. So the editor figured that out and was able to give me all those suggestions. And as soon as I choose one, the casting is done for me. More than that, if you are going to use context many times, or O many times, open the intent menu, and it's suggesting to generate the declaration for you. Done. It actually put the name of the variable right and everything. Pretty handy, right? These tips are for you guys to speed up coding. If, Alt enter, go, right? So that's intents inside an instance of. One of my favorite features is multi-cursor support. And I'm going to show you what I do with multi-cursors and how you can integrate other features of IntelliJ when you have multi-cursors. So I have a list of names here that I'm going to copy and paste inside this function. And I want to log all of them. I want to just add a log D to all of them. You know there is a completion, a template for log D, right? So you can select one and start spawning cursors on the next occurrence of the same word. If there is one that is repeated, there's a shortcut to skip it, and you keep going. And now I have all these cursors that I can do many things at the same time. Thanks. One thing I can, for example, say log D. It suggests log D. I can use the template, and it puts it in all the cursors at the same time. You can use selection per word. Start removing things like this, for example. I'm going to copy. When I copy here, it actually has one clipboard per cursor. So when I copy and I go to the end, for example, and I want to, let's say this is an email that I want to complete, I do gmail.com. You can see all the clipboards were different, and in each line I pasted a different thing. So I'm like coding at 10 times what I would be coding if it was one line. Another cool thing that you can do with cursors is I'm gonna go back to these words. I'm going to select all the names, and you can use Command-Shift-A is a super powerful shortcut. If you want to take one shortcut away from today, take Command-Shift-A. That shows you can choose any action there and apply it where you are. So I'm going to use the toggle case. Done. All the selections have been changed, and I'm logging all the names pretty quickly. Cool. The next one is navigation. Pretty useful. Command F12. It shows you all the functions in your file. One thing that IntelliJ does that is super powerful is on every menu, even if you don't see that there is a search box, there probably is one. Just start typing, and things happen like this, right? So if you want to go to a function, Command F12, and type a few letters of it, boom, you're gone. There's a shortcut to go back to where you were, navigation shortcuts. There's another cool thing that are bookmarks. I use some of this very often. You can bookmark a line, but this is not the powerful thing in my opinion, is this one. You can bookmark with Ctrl-Shift a number, and you can give functions in different files a number, and then by just pressing Control and the number, you navigate there super fast. So this is quite handy. If you run out of numbers and you want to use letters, you can. I've never got that many, but you could use Control F11 on Windows, and it opens this menu. You can choose A, for example, and there you go. You bookmark with an A. And to find them, there is this menu that shows you all the ones that you have added, and you can press A, and it takes you there. So that's bookmarks. And this one is pretty cool. You guys know that you can extract a method in IntelliJ, right? So I'm going to go, there is this for loop that I have there that I would like to be in a separate method. So I go to the middle of it, and I use the expression selection tool that it selects an expression going up and up, right? So here I have the line. Now I have the block. Now I have the if. Now I have the for loop. You know, you can go up and down depending on the configuration you have. And I selected the for loop, and now I'm going to extract it to a method. Let's call method test. What happened? So the font there is too small, but it pretty much says, hey, stop doing cut and paste and write the things properly, because IntelliJ just detected another instance of what I had in a different place. So it said, you had the same method. Do you also want to extract it? It's not using the same variables, but it figures out that if the arguments are the free variables, it's going to extract it, and both for loops are gone, and only one test method. That's the one I like the most. And you clapped on the tab versus enter. This is weird. Postfix. So, you know, you can do, if you have an array or something you can iterate over, you can do post completion and say, for example, for, and this generates the for you. You can also do for I, and this generates the very familiar for loop that you guys know. And you can also do for R, and it does the annoying reverse one for you too. There are so many of these. Just play around with them. For example, if you want an object to check whether an object is null, you can just post complete an n, and it'll do it for you. And many others like this. If you want to know them, just press Command J, and no, I didn't press Command J, and it offers a list of all the completions that you could use on an object, and you can write your own as well. Number 8, that is pretty useful, is when you have a condition that is complicated, you have a lot of booleans, and you want to simplify it, just check out what the intent menu has, because it will have things that will probably help you. So let's say I want to replace ors with ands, and this is the result. Or I want to, I don't know, split into two ifs, or revert the condition. You know, the cool thing about this is that you're not thinking. It's just, you know, it just changes, and you know for sure that it's going to be the same behavior that you had before. So there you go, a different way of writing the same function. Control space versus control shift space. This is a smart completion. So if you do control space here, you know that it offers you all the expressions that you could do there. Not all, but you know, a few chunk of them. And it chooses the one that are type correct at the top. But if you do control shift space, it gives you only the ones that have the correct type. And you can see that it's not showing before it was showing the same function as itself, but now it figures out that if you do that, you're going to probably recurse infinitely, so it's no longer showing you that. More than that, if I command this function here, that is the only other expression that it could use, and I do control shift space, there you go. It just shows the only one thing that it could do, and it put it there. So pretty handy. And the last feature that I want to show you, this has saved me so many times. You know when you say, I'm not going to commit now, I'm sure this is fine, and then you screw up? Local history to the rescue. Command-Shift-A, local history, and you have, IntelliJ has done a diff every time you were editing your file, and you have the history across your day, and you go back to the point and say, oh, this is where I screwed up. And you can see here that it's showing a diff of everything I did during the demo. 2 minutes ago, I was doing this. You can see the joins this is super, super useful. So I hope you guys enjoy this, my favorite 10 tips. And Shiva is going to show you debugger cool features. Thank you.
Thank you, Esteban. That was a number of cool features, but if you're like me, you now have really clean-looking code that doesn't work. So now you enter the debugger. So let's spend the next 10 minutes looking at some features in the debugger that might help save the day. The first thing I wanted to talk about actually 3 different things. One is how do you attach your debugger to a process, and then about how do you actually set breakpoints in slightly more interesting ways so that you can narrow down the area that you want to debug. And finally, once you're stopped, how do you examine the state of your program? First, let's start with connecting the debugger. The most often used is you would just launch the debugger through Shift F9 debug app. What this does is it does a bunch of steps that you specified in your run configuration. This has a number of cool features. You can specify what APK to install, and more importantly, what to launch. So you would normally launch the default activity, but you can launch a custom activity if you have activity aliases or some other activity that you would want to launch. Or you could also launch a URL. But what happens if you don't want to launch something, you don't want to install, you don't want to build, but you just want to connect? Let's say someone brings you a device where your program is stuck in a bad state. So in this particular case, I have a program, and it's running over here, and I just want to directly connect to it. The key is just saying attach debugger to Android process. This is also present in the toolbar. When you select this, it shows you the processes that are running on your connected device. And as soon as you say OK, you select the process, then it immediately attaches the debugger to that process. So this allows you to examine programs when they are in a messed up state. So this is good when your program has been running for a while. But what do you do if, for instance, you want to debug either a second process in your multi-process app, or you want to debug something that is, you want to attach the debugger as soon as the process starts. So Android has a nice API called debug.waitForDebugger. So what this does is that as soon as your program starts, if it's not launched through the IDE itself, and when it encounters this API, it'll just pause your program at this location so that you can then connect to it. So in this particular case, I'm going to launch this broadcast receiver. It obviously doesn't have to be this. It can be anything. So I go to the shell, and then I launch this. And now you see that the whatever you launched is actually waiting because it's waiting for the debugger to connect. At this point, you can again attach the debugger, and now you see the second process. And this will come and pause right at that the next statement. So this is really cool when you have something that you want to debug really early in your code. So that is how you attach to processes. Now let's look at, thank you. Now let's look at a few things about how do you set breakpoints in slightly more interesting ways. Let's go back here and let's run our app. And so I have a breakpoint set up. The application you saw was a pretty simple recycler view, and if this breakpoint is set in the bind view holder, it's going to stop every single time. So you can keep continuing, but this gets super annoying really soon. So the first thing that you probably want to learn is there is an option called mute breakpoints, which will disable breakpoints throughout your program, all the breakpoints that you've set. So this allows your app to continue running without the breakpoints. And then once you have your program in a certain state where you actually want the breakpoints enabled, you can enable it back again. That is like a hammer. It just disables all the breakpoints. If you want to be a little bit more, if you want to have a little more control, then you start with looking at conditional breakpoints. What I want you guys to think of is that breakpoints are not purely static. You get some control over when they are hit and what do you do when they are hit. That if you get that part, then you can just go through the list and figure out all the different options around breakpoints. The first one, let's say, is I want to say that I want to break on this position on this location only on let's say the 10th item. I'm not sure if that showed up properly, but I basically said position equals 10 as a condition there. And this means that this breakpoint will not be hit until this value, this variable position has a value of 5, and so of 10. So now I go here and I scroll, and now it hits the breakpoint only when position is actually 10. That's the conditional breakpoint. Now, there are actually a number of conditions that you can set. Let's go here. And over here, you see setting a condition is one. Another option that is really cool is instead of setting a condition, you can actually evaluate an expression. And if you turn off suspend, then this breakpoint acts pretty much like every time the breakpoint is hit, we will just log this expression over here. Let's say I want to log an expression that says as position as and I do this. So now I go to the console. The new feature in 2.3 already is that logcat gets streamed directly into your debug console. So you see the logcat over here. And then we just added a breakpoint at the end, which basically said every time it hits that breakpoint, it'll log an expression. So when I scroll over here, you will see that it keeps logging. Whenever it hits the breakpoint, it'll keep logging whatever expression that you have given. So this is extremely useful because you don't have to, like if you just want to log something, then you don't have to do a whole rebuild and deploy again. The next. Thank you. I just want to point out a few other conditional options that are there in breakpoints, which is there is one cool feature where you can say that I don't want this breakpoint, I don't want the program to pause at this breakpoint until a different breakpoint was hit. So if you specify this, then the program will pause at this breakpoint only after the subsequent breakpoint was hit. And you have even more controls. You know, there are instance filters, so you can say you only want to stop if it's for a certain object, a certain class. So now let's go over from here. So now let's look at another really cool feature that the debugger provides. So I have this okay, so this is the data which is displayed by the recycler view. And I have a whole bunch of objects. What happens if you want to track one particular object throughout the life cycle of your program? Let me go. So what I can do is, let's say I want to track what is going on with the 8th object in my list. I can attach a name to it. And this is what you do by marking that object. And so I say this is day 8. And what that immediately does is that this is equivalent of you creating a variable in the debugger and saying that this variable points to this particular object. And any time in your program, as long as that object is visible, you will see it annotated with this particular name. And this is really cool because many times you want to track one particular object. I usually used to end up writing it on a piece of paper, the object reference, then you would track it. But instead, you just have to mark the object. And then once this is done, let's say you go somewhere else in your program, and over here, you can actually see firstly, you can see that it is the same object. So in the case that it is a singleton, for instance, and you have properly marked it, you would always see it annotated with this. Not only that, you can actually use this as a conditional over here. So here I can say forecast.equals day 8. So this is the variable name I gave. And if you, the IntelliJ convention is that you add underscore debug label as a suffix, and that variable is just available to you. So now if you do this, then we will stop at this breakpoint only on whenever the forecast matches the day we mark. So this is really cool when you want to track specific objects over the course of your program. Now I want to get into evaluating expressions a little bit. So let's go over here, and I have so I have this expression, and what this says is that if the current time, if it was more than a day since the last sync, only then show a notification. But it so happens that I actually want to debug. So if I continue from here, if I step through from here, then I go into the if case. But what I really want to debug, let's say, is the else case. So now what do? Let's go back to the breakpoint again. The easiest thing to do first is you evaluate this expression. So now you see that so the result is true, so you're going to take the if case. But what I really want to do is figure out why the if case was true. So now I can see the last sync time. This is the timestamp in milliseconds, but it's pretty hard to see what exactly that means. So what you can do is you can say that I want to view this as a timestamp. Now when you do that, it actually renders it as a timestamp. Thank you. And that's pretty cool because now you see that the last sync was at noon. And so obviously the if condition will always be true. Now comes the next part. You actually want to force it. So what you do is you set the value to 0 and you close. And then you can evaluate the expression again. Now the result is false. And that's because we were basically just able to, from the debugger, set the value of an object. And you can do this actually for any field that you want. So now if you close and step, you can now get the else case without actually tweaking your program. You just change the value in the debugger. The last couple of things, so actually let me show one more thing here, is smart step. So normally when you have code like this, which is either methods which are, sorry. So I have a method like this, then typically and if I want to step into one of these methods, what used to happen is that you would actually have to step into each one, and then you get out of it, and then you go back into it. So instead there is an option called Smart Step, which will tell you exactly which particular method you want to step into. And this is really useful whenever you have methods, functions being passed in. So you have multiple parameters which take function values. And then you can select which particular method you want to step into. Now let's look at a little bit about the view over here. In this stack frame view, everything that is colored yellow is actually coming from sources that are not in your project. One tip to know is that earlier, so if I select this, we would take you to the platform sources, but the platform sources always corresponded to your target API level, not corresponding to the device that you're actually running on. Finally, in 2.2, we have fixed it so that we now show you the sources corresponding to the device. The only thing you have to do is make sure that that particular source is actually installed. We don't have a UI that comes up and says that if you install this, it'll properly show you the source. So just as long as you have the sources installed, it'll pick up the correct sources. Thank you. Finally, I want to say a couple of things about Instant Run. One really cool thing about Instant Run is that if you are debugging and Instant Run is enabled, you can actually restart an activity from here. And that would immediately, if I had launched it in Instant Run mode, it would pretty much restart the activity. You don't have to go kill it. You don't have to go to the device. And one other tip when you're using Instant Run is that you have to manually stop your use the stop button to terminate the application before running again if you want to launch to a different device. This is just a little bit of it. Because Instant Run is new, many people get confused about that. That's what I had. Hope you found it useful. Next up is Catherine, who will talk about C, C++.
Awesome. Thank you, Shiva. Right, so C and C++. I'm going to cover a little bit of edit and a little bit of debug. So on the edit front, if anyone's ever edited many JNI methods, it's really, really easy when you author it in the C or C++ side to get some name mismatch, and then you get some runtime error. We've actually got functionality in Studio, though, where you can completely avoid this problem, because when you start creating a new method, let's just make a clone of our string to JNI here. you can auto-complete it from the Studio side. I don't know, where's my button? And it creates the whole stub in C++, so you don't have to worry at all about whether you've actually gotten the right Java class path here. Once you start editing, there's a C++ tool called Doxygen, where it gives you Java-style autodocs. So let's say we want to create some sample function. We're going to add the method. Or not. Whatever. So as I create this, I can put whatever I want in there. And then you can look up the whole list, but a couple of good ones are, I think brief is the heading. This is what I do. You can say author, param. And then when you go down and hit F1, I should, if I have spelled this correctly. Oh, sorry?
Capital S.
Small s.
Oh, simple. Oh, gosh. So once I actually get my letters correct, you can see all of my docs. Return is another super handy one. Your stuff right. And yeah, it's a good way to get Java style, keep track of things. You don't have to tab back and forth all the time. Once you're done editing, we've added a bunch of functionality to the debugger for C++. So I think in the earlier talk, Tor mentioned the auto debugger, and I'm just going to start this. If you ever start the debugger hoping to catch C++ code and you're like, why is it not catching any of my native breakpoints? The first thing you should always look at is, under your app configuration, do you have this set to Java? If it's set to Java, you're going to be pretty sad. But when it's set to auto, native, or hybrid, well, if it's set to native, you're not going to catch in the Java breakpoints. But I can step into my Java breakpoint. And then I can actually set a little known feature called a memory watch point. So I can right-click on this and say add watch point. And this actually adds hardware support where whenever I touch this memory address, it's going to stop the debugger. So let's set this to any, because I'm going to be reading from it. And you can see I don't have any breakpoints set down here, just one at the very end. I start running, and since we're actually accessing the memory where I set the breakpoints, the CPU is going to stop and let us look at it with the debugger. So if you're ever trying to figure out what's going on with some crazy chunk of memory, this is a really handy way to do it. It's officially supported on x86 and the Nexus 9. The emulator, though, is a good way to get an x86 debugger environment. So once we've done that, let's take that away. And the other thing we've added to the debugger for C++ is STL support. So you can see up here, I've created a vector, and I've added a bunch of pairs to it. I can actually start expanding. It's fully aware of the STL. You can have some crazy map in here, and it should still render. And you can interact with the STL when you're evaluating your functions. I can say like vec.size. And voila. Similarly, you should be able to edit memory, see the results. So I think that's the debugger stuff we've added. Let's see if I can get us back on time. Oh, and then the other thing I should have mentioned under edit, if you're used to using C++ 11, you may have noticed that the NDK and experimental Gradle do not default to it. So you're like, auto variable error. A handy way to fix that is you can actually turn it on. So if you're using the experimental Gradle plugin and you want to use C++ 11, just add this to your NDK stanza, and you will have access to all of the handy 11 language features. And then a final tip for C++ is if you ever have a JNI error on a debug build in Studio or on an emulator, you may notice that you get this expanded stack trace. So I have an app here that is actually probably not very social. It's got this handy button for crash JNI. And if we hit this, let's just keep going. If we hit this, it actually makes an invalid JNI call. So we can't call find class with something that's not a class, and we'll get this huge stack trace. I know some folks have come saying, I'm getting all of these SIG aborts for my production build, what's happening? One thing to consider is that these stack traces actually only occur on debug builds from Studio by default and on the emulator. if you're using a real device with a production build, all you'll see is the abort. And there's a handy way to fix that, which is you can connect to a device with ADB and set check JNI to be 1, and this will enable JNI checking even if it's a production build, even if it's a physical device. So if you're seeing crazy aborts coming out, try running this and try using it to see if you've got a JNI problem causing your error. And with that, I'd like to hand it over to Jerome for some Gradle tips.
Thank you. All right. So as you know, we've worked a lot on performance of build, whether the build should be incremental or full. And some of the effort that was led by this performance work was the Instant Run technology. Now, when Instant Run got delivered, a lot of people got confused about a few things, and I would like to clarify some of them today. So first of all, the way we do Instant Run is by doing bytecode instrumentation, and we do add a few fields and a few methods, so suddenly some magic can happen and you can reload a class in a living virtual machine without having to restart the application. Now, this adding of fields and methods have sometimes thrown people over the limit of the 65K DEX file limit. And a lot of people were confused by that and not knowing how to fix it. So I thought I should explain how it is. So basically, if you hit the 65K limit, which is just what happened here, I should probably make this a little bigger. So you should get a message that will tell you that you are over the 65K limit. So as you know, the DEX file format only supports 65K methods or classes. Here I am at 70K. So to fix the problem, I just need to define one more Gradle thing to say, I want multi-DEX to be true. Okay, so when that happens, and now we can try to build, Gradle will start saying that we are allowing to build the application in separate different DEX files. Now, there's two types of multi-DEX in Android platform. There's what we call the legacy multidexing, and there is the modern or native multidexing. And depending on which platform you're targeting, we will use one or the other. Basically, before 21, you will use the legacy one, and 21 and above, you will use the modern one. The problem here is that because we are targeting MinSDK 19, by default, the legacy multidex will be used. Okay, so we still got to build, and it's 12 seconds, which is going to be our baseline for today's demo. And we're going to see this number going down as I'm starting to improve by different settings this build environment. But first, I would like to change a little bit of code, just one line, and I'm going to change this, for instance. So we also get a baseline for the incremental build. So the incremental build, we just have one file. In theory, it should be much faster, but we're going to see that because we're using legacy multidex, it's not going to be much faster. In fact, it might actually be more or less exactly the same time. 11.5, okay, so we were at 12 for the full build, 11.5 for the incremental build. I cannot say that we're doing a great job at the incremental building here. So first, what we should do is to try to switch to native multidex, because with native multidex, the virtual machine is capable of understanding natively that an application can be packaged as several DEX files, and therefore it's a lot less work for the build system to be able to handle this. So to do that, we're going to add a flavor, and this one is going to be, say, the legacy one, and that's where we're going to continue targeting 19. And then we have a new flavor that we're going to be calling modern, and this one will be targeting 21 and above. Now, if I go to the build variant, let's think first. If I go to the build variant, I'm going to switch my legacy debug to my modern debug. So now that I'm going to rebuild, do not ask me this again, please. When I'm going to rebuild, I'm going to now rebuild with the modern DEX file. And that's not going to make a huge change for the full build. So let's wait until it's doing its job. 11.6, we were at 12, so it's not great, but slightly better. But where we're going to start seeing a big difference is when we do the incremental build. Okay, so when the incremental build, we were also at 11.5 seconds. Now we are at 6. So we already divided by 2 the build time. That's good, but I'm sure we can do better. Keep your claps for now. First thing that you should always try to do is to use the latest Gradle plugin, because we always try to enhance stuff. Yes, sometimes we break stuff, but we try to fix it. But for most of the time, we try to make things better. And using the latest version will allow you to use the latest enhancements. So in this case, I'm going to switch to the latest version. And I'm going to continue building exactly the same way. But because I want to force a complete rebuild, let me clean it first. And run a full build. So here, I'm getting another type of message. And it's telling me that starting with 2.2, we made things better. You can now run your DEX in process, which is going to make things faster. But unfortunately, in this particular instance, you don't have enough memory. And therefore, we reverted to the old out-of-process stuff. So let's add more memory to the Gradle daemon. And I cannot stress how important this can be when you will start using the Gradle 2.2. You should really look into adding more memory to the Gradle daemon. So here I'm adding 4G, and I'm going to do exactly the same thing again. I'm going to clean the project, so we get the new baseline for the full build. So in this case, the message should be gone, and it is gone. So now we are now in process, and we were about 12 seconds earlier. We are down to 9 seconds for the full build. It's pretty okay. Let's continue trying to see how much it would take to make an incremental change now. All right, 2.3 seconds. This is getting better, but we can do more. No, we can do more. Next thing, Instant Run has been disabled so far. So let's put it back on. So when Instant Run is on, we will try to redeliver the smallest set of changes each time you do a build. So again, let me clean it so we are sure to have a clean environment to start with. So Instant Run will not only try to reload classes in the virtual machine without even restarting the application, but it will also concentrate very much into redelivering the minimum set of changes required. So in this particular case, excuse me, in this particular case, when you change a single Java file, it will most likely only redeliver the DEX file that corresponds to this single Java file. So that was the full build. Now let's change again this, and let's measure how much we are down to. 0.6. Now we are talking. I'm pretty sure. Right. Even better, I can go to 0.4. Okay, so as you can see, we start at 12 seconds. We are now at 0.4. Very, very little changes, very little work. We divided by more than 20 times the build time. But let's do some other changes. For instance, let's take the source files here, and let's look into the main file. Oh, this is really small here. Actually, I don't have to do this. I can go to the app. So as you can see here, I've got a version code, which is 1. Let me change it to 5. And let's see how that influences the build. 3 seconds. What happened? I was at 0.4, now I'm at 3 seconds. Well, what happened is that we changed the main manifest. And when that happens, the only way we can redeliver the manifest file is by redelivering the full APK. So you can see how some of the changes that you make have a very strong influence. And knowing the tool, knowing what the tool does, is very important. Here, if you, for instance, are smart and try to change the version every single time you build by using the current time right now as your version, you're going to see that you will never, ever leverage Instant Run features. Okay? So it's important to remember that. But again, understand the tools. There's a lot of documentation about Instant Run. I'm afraid we don't have time for QA. We have only 30 seconds. But we will be available outside for QA. And then we have the booth, which is right outside on this side for the Android Studio, where you're more than welcome to come and ask for further questions. Thank you very much.